Hello, good morning everyone. Class 9 work on energy chapter. First part work on we have already done. We are going to do today the next part energy. What is energy? Energy is the ability or the capacity to do work. If a body has some energy, it will be able to do some work. If a body has more energy, it will be able to do more work. Less energy, it will be able to do less work. How does a body do work if it has some energy? Suppose a body has some energy, then when this body will act upon another body, then what will happen? Force will be exerted by the body possessing energy on the other body, and in this way the other body will be able to do some changes in them. It will be able to show some result, and we say that the work is done. For example, when we are cutting a log of wood, what is happening? We take an axe, we put it upward, lift it upward, and then we strike on the log of wood. It so happens that when we are lifting it, then it is possessing some energy, and then when we are striking it on the log of wood, then the energy from the axe is transferred into that wood, and hence we are able to cut the log of wood. This is just an example how energy does work. Our body having energy is capable of doing work. Next we have energy is a scalar quantity. Energy is a scalar quantity. Why it is a scalar quantity? Because in order to express energy, we don't need direction. Just we have to tell the magnitude, how much energy, what value, numerical value. Now we have the SI unit of energy. The SI unit of energy is joule, and in short we write capital J. It is in honor of the scientist who found out about energy and told us. In order to give honor to him, his full name was James Prescott Joule. So in order to give honor to this person who had found out about energy, the SI unit of energy is Joule. CGS unit of energy is Arch. Earlier used units are calorie and kilocalorie. 1 joule of energy is equal to 10 to the power 5 Arch. 1 kilocalorie is equal to 1000 calorie. Next we have types of energy. There are various types of energy: kinetic energy, potential energy, nuclear energy, solar energy, heat energy, light energy, muscular energy, sound energy, electrical energy, and many more are there. But in our syllabus we have got only mainly 2 types, that is our potential energy and kinetic energy. We will deal about them only. So let us start. About kinetic energy. What is kinetic energy? Kinetic energy is the energy possessed by a body due to motion. When a body is in motion, it it is possessing kinetic energy, or the energy possessed by a body by virtue of its motion, we call it kinetic energy. So whatever bodies we are seeing, they are in motion, that means they are having energy in them because of the motion. Suppose a bowler throws a ball and that ball comes and hits the stump and the batsman is out, then how does that stump move, or it is moved away from its place? Because the ball which had been thrown by the bowler was moving, it was having some kinetic energy. When it is struck with the stump, it so happened that the energy from the ball got transferred into the stump. Similarly, we see many examples in our day-to-day life of bodies possessing kinetic energy. The runners, they possess kinetic energy. The moving bicycle, the moving train, the moving bike, the moving fan, all of them are having kinetic energy. It may be that the energy has been transferred from some other form. For example, in our electric fan we can see that the electrical energy is being converted into kinetic energy. In our bike, what we see, the chemical energy is being converted into kinetic energy, and because of that the bike is able to move. In the case of bicycle, what we see, our muscular energy is being converted into kinetic energy. So there may be that kinetic energy is a result of some other form of energy. That's why it is told that in the law of conservation of energy, it has been told that energy can neither be created nor can be destroyed. It can only be changed from one form to another form. About that we will see in the later part. Now we will see the formula for the kinetic energy. The formula for kinetic energy we write is equal to half mv square, where m means mass of the body, m is equal to mass of the body, where v is equal to velocity of the body. So what we are seeing here, that the kinetic energy is dependent on two factors. A body possessing kinetic energy, the amount of kinetic energy a body will possess will depend on two factors, mass and velocity. If we are increasing the mass and we keep the velocity constant, then also kinetic energy will increase. If we keep the mass constant and we increase the velocity, then also what will happen? The kinetic energy will increase. Now if I double the mass, then what will happen? The kinetic energy will get doubled. If I double the mass, what will happen? The kinetic energy will get doubled. If I double the velocity, what will happen? The kinetic energy will get 4 times. It will become 4 times. Why? Because on the v we have a square. So 2, if I make it, for example, let me explain you. For example, we see that here the mass is m. Now if I will double the mass, what will happen? It will become 2m into v square. So 2 you take out common, is equal to half mv square. So if I am doubling the mass, what has happened? The overall kinetic energy has become doubled. Now if I double the velocity, see what will be the final kinetic energy? Half into m. M I will keep same. I am not making any change in the m. What will happen? I am making a change in the velocity. So 2v whole square. So what will become? Half into m into 2 to the 4 v square. 4 I will take common. So it will be what? 1 by 2 mv square. So what we are seeing, overall the resultant kinetic energy will be 4 times the previous kinetic energy. What we see, the bodies that have got more mass or more kinetic energy, they are possessing more kinetic energy. Bodies having more mass. For example, we have big vehicles like the Hiva. they are moving at our truck. They are moving at very high speed, and they are having high weight also, mass also. Mass is also more. So when mass is more and velocity is also more, then they possess much kinetic energy. And a body is small in mass, less in mass, and velocity also less, then what will happen? The kinetic energy will also will be less. For example, a small car you must have heard about the nano car. The nano car and other smaller cars, what they have? Their mass is also less and their velocity is also less. So what happens? Their kinetic energy will be less. So we can say that the kinetic energy of the body depends on the mass as well as on the velocity of the body, and hence the overall kinetic energy of a body can be changed by changing either of these. Either you change the mass or you change the velocity. The kinetic energy will change. If you want to increase, you have to increase either of these. If you want to decrease, you have to decrease either of these. Next we have about the numericals based on kinetic energy. Let us take one question. Suppose the question is, find the kinetic energy possessed by a body of mass 5 kg moving with a velocity of 25 meter per, or just take 5 meter per second. So how will we solve? We will solve in this way. You know the formula of kinetic energy. Kinetic energy is equal to half mv square. Half mass is 5 kg and velocity is 5 meter per second whole square. So 1 by 2 into 5 into 25 kg meter square per second square, and we will write 125 by 2 joule, or we divide and write 62.5 joules. Find the kinetic energy possessed by a body of mass 5 kg moving with a velocity of 5 meter per second. Suppose you are given another question. What will be the kinetic energy of a body if the mass is doubled and velocity is halved? See, let us take in the previous case that the kinetic energy is equal to half mv square. Now, what is happening? M is becoming 2m because the mass is doubled and the velocity is becoming half v. You can write m dash v dash also. So what is happening? Velocity is half. What will be the kinetic energy of body if the mass is doubled and the velocity is half? So kinetic energy is equal to half mv square. Instead of m, what will I write? 2m. Instead of v, what will I write? half V whole square. So 1 by 2 into 2m into 1 by 4 V square. Now we will cancel. 1 by 4 I will take out. It will be mv square. Or we can write in this way also. 1 by 2 you keep and half you keep inside. So this 2 you leave it here only. 2 1 2, 2 to the 4 you cancel. So what we will get? This 1 by 2 will be out. This 2 I will keep here in the same way. This 2 1 2, 2 2 4. So this half will be here and here what is 1 by 2 mv square. And this was my previous kinetic energy. So we can say it is half. So kinetic energy will also become half. So what will be the answer? That the kinetic energy of the body will be half if the mass is doubled and velocity is doubled. Next part we will see potential energy. What is potential energy? The energy possessed by a body by virtue of its position. That is known as potential energy. Potential energy will also have the same SI unit and CGS unit or earlier used unit as we have got in the case of energy, because kinetic energy, potential energy, all are there types of energy. So the SI unit, CGS unit and other units will remain the same. Now we have types of potential energy. We have two types of potential energy. Gravitational potential energy and elastic potential energy. What is gravitational potential energy? When a body is taken above the ground, that means away from the earth, that means against the gravity, then the body possesses some potential energy. So the energy possessed by a body when it is moved against the gravity is known as gravitational potential energy. For example, a brick is lying on the ground or your school bag is lying on the ground. You are picking up your school bag and taking it on your shoulder. On your back you are putting, or just you are lifting in your hand. Then that is, the bag will possess gravitational potential energy. Next we have so many examples we see day to day life. The workers taking the bricks. We are ourselves going upward from one storage to another storage. First floor to second floor, third floor, like that. When we are moving upward, that means we are going away from the earth. That means we are gaining height. That means we are moving against the gravity. That is, gravitational potential energy is possessed by such bodies. Now we have elastic potential energy. What is this elastic potential energy? This elastic potential energy is such type of energy, such type of potential energy that will make a change in the shape, size of the body. Maybe because of the twisting, maybe because of compressing, or maybe because of stretching. If I stretch a rubber band, if I compress some pieces of paper, or if I twist paper or cloth, then the potential energy possessed in that body will be known as elastic potential energy. Now we have the formula for potential energy. Potential energy is equal to mgh, mass into gravity into height. I told you it is mainly against the gravity, potential energy. It is because of the position, because of the change in the height. So potential energy is equal to mgh, mass into gravity into height. SI unit I have already told. Now we will do some numericals on it. For example, let us take an example. Now find the potential energy of a body placed at a height of 10 meter having mass 20 kg. So what we are given that the find the potential energy of a body placed at a height of 10 meter having mass 20 kg. So how will we do the solution? Potential energy is equal to m into g into h. Mass is 20 kg. As lesson g value we are not given, we will always take 9.8 meter per second square, and height we will take 10. Now multiply this. 1960 joules. This is the answer. Now what we will see, what are the factors on which the potential energy depends. The factors on which the potential energy depends are mass, acceleration due to gravity, and height. Usually in a locality, in an area, the value of g does not change. And you have studied in the Gravitational chapter how does the g changes. So, and usually in numericals what will happen, g value will be given to you. So, if we see g for a certain area, for a certain locality, then it's up to a large distance the g value remains same on the surface of the earth. We can say when we go away from the equator towards the pole, or we move from the pole towards the equator, then the value of g will change. Or when we go at the center of the earth, or we go much higher up above the surface of the earth, then only the value of g will change. So on g also it depends, but usually we will given numericals, then in that g value will be given to us. Next we have mass. So if we are given different masses, or if the value of mass will change, the value of potential energy will change. If the value of height will change. Suppose I take a brick up to a first floor, and from there I drop a floor. Then what energy, what potential energy it was having, it will change when I take the same brick from to the second floor, and from there I drop. Because the height is changing. So the potential energy will change with the change in the mass, change in the g, and change in the height. So when mass will change, height will change, gravity will change, potential energy will change. When we will increase them, the potential energy will also increase. When we will decrease them, the potential energy will also decrease, because potential energy is directly proportional to all of these factors. So today we will see up to here only. Your homework is to revise what has been taught, solve the numericals based on these formulas from your book. Many more questions are given in your book, and to practice them, learn their definitions. Next part we will see another day.